Okay, today we want to talk about importing data into the database. In the last couple of weeks, we have covered some of the basics about DuckDB, SQL, and also mostly dealing with CSV. So those are basically tabular data, non-geospatial. And starting from today, we're going to deal with spatial data. So how do you actually get the data into the database? How do you do some manipulation? And then you can also export the data out. So this lecture and the next couple ones are critical if you really want to utilize the database for doing some spatial analysis or doing the manipulation, and especially useful if you're dealing with large amount of data sets. And so in terms of the database for geospatial, right now DuckDB only supports vector data. So you can do with GeoJSON, shapefile, GeoPackage. Pretty much any vector dataset supported by GDAL, you can actually open and load it into the database, and then you can quickly do filtering, do selection, do aggregation, just like what we have been doing for the CSV. It's the same thing, but there's a spatial column called geometry that you have to deal with. So for today, I want to cover most of the common formats: CSV, JSON, data frames, Parquet, GeoJSON, shapefile, GeoParquet, and any other vector data format. So here, we're going to do the same thing. And for this lecture, we're going to just use the Python API. So we don't use the SQL magic command using pure Python. And let's go back to the notebook here. Okay, so the besides using DuckDB, I'm also using LeafMap. We covered that at the beginning of the semester. So in here, we're just using LeafMap to download some sample data. But later on this course, we're going to use LeafMap also for visualizing some vector data set. For now, we're just using it for downloading data. So if you run the source code, if it doesn't work, then probably need to import, install the package. So pip install LeafMap, then you should be able to install it. And then you can create the database. So by default, right, just DuckDB.connect. If you don't provide anything, it will just be a database in the memory. So, but I can provide one here. For example, I can say spatial.db if you want to. So in that way, it's going to save the data to the database, and then just assign it to available connection. And then from there, you can install the extensions. So here, keep it in mind, in this notebook, you need to use two extensions. The first one is HTTPFS. So that one allows DuckDB to read data from the internet. So either through HTTP or AWS S3 bucket or GCS or any other online. So otherwise, you can only deal with data on your computer. The second extension is called Spatial. Okay, so this is the one that we need if you want to read spatial data into the database. And I can show you where do we actually find the extension, right? So this, think about just like Python. You can think about Python. You try to install packages. So for DuckDB, if you want, I think I showed this before. So after you have create the connection, you can always like SQL, con.sql, and then you can select, okay, start from. So this is the function that we used before, DuckDB extensions, txt enslons. Okay, and you can run it. You should be able to see parentheses. Yeah, so parentheses, and then run it. Okay, so this shows you some of the extensions supported by DuckDB. And if you look at the list, right, HTTP FS is here. So this one is called the built-in. Oh, not the built. Oh, it's install, so not the built-in. I already installed it before. And the second one is called Spatial here, right? And you know some of those built-in. Built-in means kind of like the core extensions is automatically loaded when you import a DuckDB. There's some extension. For example, this one is installed to you actually, if you open it, you can open it. It's under, if you have your mouse, it's under your user directory and then DuckDB. So if you really want to check like where are those, right now you haven't installed yet. So for you, you don't see anything yet. But I'm showing these are some of the officially supported extensions. And then Things are already installed, I don't need to install again. You can just load the extension. But for you, if this is the first time you run this too, and so what this is doing is install the extension and then load the extension. So like I said, it's being installed to your user directory. So if you go to your C drive, I mean under your name, you should be able to find the directory. So go to here and then users under your name, and there should be a hidden folder somewhere called DuckDB. Right? So if you see here DuckDB, and then click in extension, the version of the DuckDB, and then your operating system. You see this? So this is actually the one that's the Spatial and HTTPS. So you can think about installing the file and then install on a computer. So when we're using the extension, it's actually utilizing this executable somehow. It's already compiled, so we cannot see the content. But just let you know, if you install additional packages, it will actually come here. So let me try another one. What else? How about AWS, for example? Okay, so if you want to, I can come here and then change this one to AWS. Okay, AWS. If you run it, it should take a couple seconds to download the extension, and I would imagine it's come here. See that? AWS DuckDB extension. So it's connecting to this file to use to load the stuff. So once it's loaded, now we can start importing the data. But first we need to have some sample data. So this sample data comes from my GitHub account. So it's just a zip file, and if you just run it, it should download this one to your current directory and then automatically unzip the directory, right? So if you see here, DuckDB and then cities.zip file on the left side. So now you see a bunch of file formats, vector data that I just downloaded. All right, so you can open your directory, see here, and go inside book DuckDB. So the cities dataset basically include a GeoJSON, a CSV, a JSON file, a Parquet file, and also a thread file. So basically a bunch of vector format that we can explore, and it's a very tiny data set. In the last lecture, we actually used this one, the CSV, right? But right now we are dealing with vector data, different vector data format here. Since we have the data set, then we can start reading, right? So the first one here, the read CSV, is the same one that we used last time, right? And so you can use con.read CSV. If you run it, it's going to return the result and the output, show it to you. Besides using this way, if I'm using the SQL statement, how should we do that? Without using a read CSV function. Con dot SQL, and then okay, it looks pretty intelligent. Select star from this one. Is not, it doesn't work yet because we have not created a table. So you need to actually read the file, so you can be because I use double quote, so you need to double quote outside so that you can use the file name single quotes inside. So it should be like this. Okay, select star from cities. You need the single quotes. Cities dot CSV. Okay, and then single quote. So this is the same. This one is the same as this one. So either way, it's fine. You can use the read CSV, and then in there you can pass in a bunch of parameters. So the read CSV is kind of very similar to the pandas data frame. So you can pass in like some of the things. For example, you can say header equal to false. That means you're not going to read the header. Then this will be gone. Okay, this ID name or something like that. Is there something wrong here? Or is it period? So it should be a comma. Right? If I run it, see that? So now it's like the header is being treated as data rather than as a column header. But usually you want to say it's true, and then Control Enter. All right, so now this is correctly. So usually it should be pretty smart. If it doesn't, then you can specify those parameters just like a pandas data frame. Or you can do this way. It's up to you. So these are the way they can load the data into CSV, like in here, right? You can specify the header, also the separator, so the delimiter, right? So it's by comma. But if your CSV happens to be like any other tab delimited or something else, then you need to go in here. So this is about read CSV, and there's also another one here. I call parallel. Parallel means like a little bit faster, so you can read the file much faster. But in this case, it's a small file, so it doesn't really make much difference. But if you're reading a CSV that has gigabyte of data, you might try this one. It's so much faster. And like I said, DuckDB can read the file the size much larger than your memory. So you have 16 gigabyte memory, it's supposed to be able to read more than 16 gigabyte. So if you have a CSV file that's that big, you can do that as well. And we already talked about this one, right? So you can do the same thing, read the CSV. You can also use this function. So the read CSV auto users also be pretty smart. But if it doesn't work, then you just read CSV and then pass in the parameters, just like what we did earlier. So these are pretty much the same result. So it's very flexible. There are multiple ways you can read the data, load the data into a database. So simply right now, we're just reading the data. We didn't create a table or anything. And so DuckDB, the 3 file format that it supports, like has native support. The first one is CSV, the second one is JSON, and the third one is Parquet. So those are the 3 files that it's very easy to read. It has native support, and you can read a lot of files. Let me show you something else. I'm doing here. So for example, they say I have this CSV file here. This city is of CSV. Sometimes you might have a bunch of CSV. They have the same structure, the same number of columns, the same name. For example, you can have a US state, for example, like county. For every state, you can have 50 files. In the past, you have to read like one by one. But if you're using DuckDB, you can actually read all the files all at once. So I can show you here. I can create a new file just to show you, like, to demonstrate what it looks like. So I can say cities 2 CSV, okay? And assume that I have another file similar. I'm going to copy this. Okay. And maybe let me delete some of the links in here. Yeah, maybe not delete it. Okay. Or how about I go to the end? I grab some. Anyway, I think this is fine. So let me do it here. Okay. 2 files. And let me, is it under here? Yeah. Cities took 2, right? I can create another one. Cities took CSV. Oh, 3. 3 took CSV. Do the same thing. I'm going to copy another one. You just assume that the data are different. I'm just showing you like how to read multiple files together. So right now I have 3 files under here, right? If you're using, for example, pandas, trying to read the CSV file, you like read CSV, open, or you have a loop. But DuckDB is so much easier. So let me show you what it looks like. So I'm going to create a new code block here. Okay, so conda, I'm not conda, sorry. Conda right? And then it should be select star from, and then you can just do what is star.csv. I'm not sure if it works or not. Single quotes, I think single here, double quote, and then double quotes here, maybe like this. Character. Do I have multiple CSV here? I forgot what I did. There's the example at the end here, kind of similar to this one from blah blah and then star. Yeah, maybe I need to put a file path in here. So let me. Okay, do I need a single quote or double quote? Yeah, I do. Okay, so you'll be here is star, and then Is there something? Yeah, this one's work. I'm not sure if the file has some issues. Number 2, number 3. No, it should not be. Yeah, there's something wrong. Expecting wrong new line identifier. That's interesting. So it might be just the file. Let me enter this one, space, space, and let's try again. Usually it works. CSV. Little file. Yeah, it's work. I'm not quite sure what is the issue here. Anyway, I will investigate. So I tested before in other files, not the CSV. It works just fine. So which one? It's the same. So this is supposed to be working. If the file is the exact same format, there's some. If you do it individually, it works fine. So there's no reason that it should. New line identifier. Or I can do this. It might be just the file. Something is weird. So how about this? Let me delete these 2 files. And let me just copy paste. Usually the file. Sometimes you create a new file because of the new line. So oops. So I can use this one is city2. And let's see if it works here. Yeah, so that means just the new file. The new file they are created. Sometimes they have some like weird format inside. So now you see it works, right? So I have 2 2400. Originally if there's only one, there is only maybe like this one here. Right. 1249 cities in the file. So now it doesn't matter how many files you have. I can just like in here copy, paste, 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 paste. How many you have? Like 10 or 9. It doesn't matter, right? So all you need to do, it automatically combine all the files. So all I need to do right now, you can just, if your folder only has one CSV or have a lot of CSV. In this case, I can just city star, but I can also like star CSV is the same. So take a look. See how far is this? How long does it take? 0.2 seconds. So if you want to use like pandas, like you need to write the loop, get the file. Isn't this so much easier? Right? And it doesn't tell you how many rows because it's larger than 10,000. So if you really want to count, you can simple, right? Count, start. See how fast it is? 13,000. It's just like second, less than 1 second. Good luck if you try to open the file individually. Click, 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 and come manually. And it's not just this, right? You can do all kinds of statistics. So you can do like summarize, you can describe, or I can, for example, after you select this, you can get, for example, the average of the column. So for example, here, let's say population, right? You're trying to figure out what's the average population. How do I do that? Okay, select average, right? Yeah. Or maybe total, makes more sense. Okay, and then population. See how fast it is. Now you slowly, if you're doing like this batch processing, this is going to save you tons of time. And it's the same thing. If you're looking at vector data, CSV or GeoJSON, Spatial, it's the same workflow. Once you load the data into a database, and then you can process a bunch of them. So this is really, really powerful, very fast. Yes. Yeah, you need to have same column. Otherwise, it cannot. It cannot. You need to handle that process the file. Make sure that they the same structure, same column names, but different rows, and then you can combine all together.
So if one of them,
yeah, you probably will fail because it's not consistent. Maybe we handle that. I don't know. You can try to delete some columns, see if it works.
because I think the problem you had for your created file is that one of the files still doesn't have a column.
Oh, really?
Yeah.
I forgot. But anyway, so the file, just make sure they are consistent, then you can do that. And it's super fast. 0.2 seconds, right? And right now only have like 11 files, but it doesn't matter. You can have hundreds, thousands. You'll be the same. So imagine in the future, if I doing some like repeated data processing, and need to do some aggregation, do something like one line of code, one line. And you can get the result. You can return it. You can turn that into a Panda data frame. You can save the data. So but people don't know about database. You told them like open the data, how do I read the CSV? But this essentially is just a couple lines of code. Okay, so this about the CSV. Next, JSON. So it's pretty much the same. I also have the JSON file here. If you copy that, it's basically it's a list, and then within there you have multiple columns. So it's just a simple plain text JSON file. You can do the same thing. Just read JSON, right? And there's not difference. It's select star from city.csv, 60.json, or you can read json.auto. So it's pretty much the same as the data frame. And this is the second way, okay? So traditionally, if you're using Python using the pandas data frame, you can just pd.read CSV, right? So if you need to read multiple files, you need to like do a loop and then just need to append, need to merge, right? I can read the cities 2.csv, like the same thing. You can read all of them, whatever you like. The nice thing about this is like the data DuckDB also support data frame. So if you see this line here, right? Earlier we used select star from single quotes, cities.csv, cities.json, whatever. You can just pass in a variable name, a pandas data frame, because we read this one and then passing this one. So you can think about DuckDB can read not only physical files, it can also read things from a variable, a pandas data frame. So this makes it nice because you can think about some of the things that you cannot do using DuckDB. It has to use the pandas data frame or NumPy to do data processing. And after you finish the manipulation, you don't need to save that one in the CSV or JSON or whatever. You can just read the variable. You're able to treat it as a table. You see, now I can read the file. I can fetch all means you're getting all the results and then turn that into a Python object. So in here, this is actually a list. So if you use the fetch all, it becomes a list. Then you can actually manipulate the object, right? So it's a list. I can just, for example, select the first one, right? And then you can, for example, select. You can do the indexing, so you can get to the result you want. CSV, JSON, and the third one is Parquet. So as I mentioned in the previous lecture, Parquet you can think about is a CSV, but it stores data by column, not by row. So that means in memory, data in the same column, it's called chunk. So it's put into the memory, it's together. So and then you have some metadata to point to you where's the next one. So it makes it really much faster to search. If you by row, you need to load all the data. So even if you only need a specific column, you need to read the data for the entire row, and then you need to go through them. So it's not very efficient. And sometimes if you have hundreds of columns, if your file is 1 GB, that column probably is only like a couple megabytes. So the Parquet file can actually just very efficient, can read just a couple megabytes. But if it's by row CSV, you need to read the entire file. So this is why it's not very efficient. So this Parquet file is the one that actually based on the GeoJSON I saved to Parquet, export to Parquet. We talk about it next time. But for now, assume that okay, you have this Parquet file. It's a vector data. You can just read it just like a CSV. Do the same thing in here. The only thing that you notice here is the geometry column, and it have this like binary code that you cannot really understand. So that means there's a geometry column here, just like you open a shapefile in ArcGIS or QGIS, and there's a column called geometry, and then say polygon, polyline or point, but it doesn't tell you like what's the coordinates there because it's encoded. So this is that column, but the database right now by default DuckDB doesn't support vector data, so that's why we need the spatial extension. But for now, if you're trying to read a file or it's already have this column, you want to show it like this. It's called blob. Blob storage basically means just like binary, 0 and 1, 0 and 1, but it's like hex code, so you cannot really understand what's in there. But you also have other columns in here, right? And later I'm going to show you how you can actually convert it into vector data. For now, just treat it as a table. So this, if you treat it as a table, it's the same in here. Select star from the file name, select star from read CSV, read JSON, read Parquet. It's the same format. So you want to get the same result. Make sense? So it should be pretty simple. So the recommendation will be like this. If your file is the CSV JSON or Parquet, just select star from, just passing the file name, single quotes. That's it. And if it doesn't work, if you need more precise control, then you select star from read CSV underscore, read JSON, read Parquet, and then can pass in the parameters. So in that way, if something like automated, it's not working, then you passing the parameter to have fine control about how you want the file to read. Do you want to have header, or do you want to check the delimiter, whatever? Questions? So that's the non-spatial data. So next, let's talk about spatial data. And the common one, for example, GeoJSON. Before we do that, I want to show you like what kind of a file format are supported. So if you select this one, select start from AST driver. So they basically they one is the GDAL driver. So for those of you who have never used that, GDAL basically is like a library that allows you to read all kind of vector data format, geospatial data format. So in here, there's a total of 51 rows. So maybe 51 file format, and pretty much all the vector data format that you encounter is supported in here. So this one, the ST drivers, this one is come from the DuckDB spatial extension. So you need the DuckDB spatial extension to be able to run this one. And let me quickly show you here, DuckDB.org. And then if you go to the documentation, extensions, spatial, and here, if you scroll down, I'm not sure if it has a list in here. No, yeah. So the spatial extensions, so these are all the drivers. Besides H3 Shapefile, GeoJSON, but GeoPackage, OpenFileDB. You can even read ArcGIS file database if you want to. And then GeoPackage, log uploads in here. So in total, there are 51 vector data format being supported. So next, let's talk about how we can read the file. And if you look at this one, it's pretty much the same, except that if it is a vector format, now you need to use this function ast_read, and then passing the file name. So this function, if you want to find out, okay, where this come from, it's come from here. So this is where this file extension is about. It's st.read. st_read. You see, read the spatial data table. And this one can read any vector data format supported, like 51, as I mentioned earlier. You pass in the file name, and there also are a bunch of other parameters you can you can pass in, but usually it should be pretty intelligent. So just put this function and then put the file name inside. Similar to the JSON, CSV, and Parquet, right? You don't need to write put the function name. But this one you will need to, otherwise it won't be able to recognize. So you see, read the file. So if you don't do that, let me show you here. See, open, and let me remove this one. Right. So native support means it's just JSON file, CSV, and others. I'm not sure if this one works. You see, it will tell you table with digitization that Is there something wrong here? Or the schema, okay, it doesn't exist, whatever. But actually exists. You just need to tell, like, okay, this is a vector data format. I need to use the spatial extension to read it. So all we need is just put st underscore read. That's it. So now you can read the vector data, and from here, see this nicely. So now it shows you the point compared to the one that we saw earlier, right? This one is the Parquet file, although it's vector data column, but you cannot actually see it. But for this one, clearly, this one is much better. Okay, so JSON, and or you can just from, you don't need to select star if you want to show all the columns. Then you can just from st to read, blah blah blah. Same idea. Next one, this is where you actually store the data in the database. So similar to what we did before, create table, and the name of the table is, and then select star from blah blah blah, right? So you get all the data, create the data table, and then run it. So it doesn't show you. So now you should have the data table in there. So you don't need to use the file name again. You can just refer to the name of the table. Okay. So now you see the data table is already inside. So I can just show the data, the content of the data table, and you can from there you can just run this one, select star from cities. So now this cities is the data table is in the database. It's not in your computer on the hard drive. It's not a CSV, a GeoJSON anymore. So it's in the database, and look nicely. You have all the column. You also have the point. So this one is the geometry column. It's not a plain text column, but it shows you look like that. So this is the GeoJSON, and pretty much the same for Spatial, right? I also in here earlier download you, right? .ssp, and so all we need the same thing. Select from st underscore read. St underscore read. That's the only thing that you need to remember, is to read vector data. But if it is CSV GeoJSON packet, then you don't need to. Or you can just read CSV, read JSON, read packet if you want to. But like I said, DuckDB has better support for those. But for vector data set, you will need this. Okay, same file content, because this is the vector data. And like I said, you can read any vector data format from there, 51 data format. And same thing here, right? Read the strap file. And similar to the GeoJSON, now we can create a new table, right? So create table, if not exist, I'm creating city2, and then select all the content from the Esri strap file. And if you run it, it's going to create a new table. So now I have table cities2, right? Also, if you want, like for example, if it doesn't exist, you create, but if it already exists, it won't do anything. If you want to overwrite, then you want to create or replace table. Then in that way, you will just always replace the table. So it'll be something like this: create or replace table, and so then we don't need the if it not exist. So this one we always overwrite, right? So right now, although my database already has the cities2 table in there, so here we just use replace. So when I run this one again, you should just replace the table. Although the content is the same, so I'm just showing you that when you're trying to create a table, there are two ways: override or not override, right? So if you want to override, then use create or replace. If you don't want to override, then it means like create table if not exist, and then something like that. Otherwise, if you just say create table and then cities2, would this work? But run this one, would it work? Create table, cities2? No, right? Because the table already exists. You cannot do that. I'm gonna show you blah blah table name already exists. That's why you need to say if not exist or replace. So if it replace, you will run it. You just delete the table and then overwrite the table. The third one is GeoPacket. Okay, so this one, you will notice in here, this file, we have done this earlier, right? We select something from, because DuckDB support the Parquet file, so we don't need to write. We don't need to use the function to read it. And if you run this one again, right? I already showed you the result earlier. This is the outcome. But because we know it's a vector data, you have the geometry column. So this is where you can actually read the data and then convert it to vector data format. So pay attention here. For this line, you only understand, right? Create the table if it doesn't exist, and select star exclude geometry. So what this one is doing is it's going to create a table, and it will get all the columns except this one, because this column is vector data, it's encoded, so it's binary. We don't want this one to show up in the attribute table. Okay, but there's a function. This is the spatial treatment of that column, st geometry from WKB. So if you don't know where it's come from here. I'll show you the function here. Geometry, st geometry from WKB, blob, right? Blob storage. So what this one is doing is, okay, I know you have the data table, you have a bunch of columns, and there's a spatial column called geometry. And but that one is like have binary, like spatial encoding. So what this one is doing is, okay, give me all the other columns except this geometry, and then that one I'm gonna put in the table. And then I create the geometry column. Is use this function because it's a spatial column, it's geometry, and I use the spatial extension to tell that read that one as a blob storage and then create the geometry. So basically, geometry from that column. Otherwise, just a regular data table, it doesn't know it's a geometry. So this is something that you will need to understand. Like for all the vector data set, if they're doing the Parquet file, then you will need to do something like this. So usually select star, exclude, select star from like all the columns, exclude the geometry, and then I'm going to do something with the geometry, and then using this function. After that, okay, as geometry, so basically means I read this column and then rename the column as geometry from this city Parquet file. And if I run it, okay, it's done. Then I can show you the data table in there. So if you scroll up, see this one? Compared to this one, right? So earlier, basically, we select all the columns except this one. So I ignore this second column, but I create another column called geometry. It's basically process this geometry column and then put at the end. Look at here. Make sense? So now you are actually reading a Parquet file, and then you can open it. And the nice thing about this is similar to what we did earlier. You can deal with hundreds of files or Parquet files. So if I go back to here, right, let's show you the magic. So city is the Parquet, right? Assume that you have a bunch of those files. So just copy, paste. How many do I have? Okay, 4 or 5. Enough. And now if I come back to here, yeah, I'm not quite sure if I can do that or not. Maybe. So you'll be like city is the Parquet, right? Just like what we did earlier, that's CSV. I'm not sure if it works or not. Let's try. Okay, perfect. So now let's run this table. How many rows? Okay. Oh, if not exists, so you need to create or replace table. Or replace. And let me remove this one. Nice. Okay. On this one. Okay. So that means you can read multiple files. But you need to be Parquet. It doesn't support GeoJSON or set file yet. I'll show you how you can do that next time. But just that you know, this is like super efficient. And you see like less than 1 second. 0.0 seconds. And it doesn't matter how many you have, like you can have hundreds. You can read all the file all at once. So again, make sure you understand this doing here. Of course, you don't necessarily have to as geometry. As means basically rename the column. If you don't do that, it will be the column name will be like this, just like this. So you will remove it. Just pay attention here. Pay attention to the earlier output, right? Geometry. If you don't do that, you'll be like this. Oops. The column name will be very, very long. It will like the name of your statement. So usually you want to rename it as geometry or GOM so that it's much more intuitive. Okay. So now we have this data table. Pretty nice. And besides reading the Parquet file from your computer, you cannot actually read files directly from the cloud. So this is where so-called cloud native. So the Parquet file, you can store it anywhere, and we don't have to download it. So imagine you have a bunch of files that's pretty big, like gigabyte data, but you only need a small portion. This is called S3, so AWS S3. So it's stored in the S3 bucket. But now, do you understand these two lines? Yes? Select star, execute geometry, and star, blah, blah. The only difference right now, instead of like city star doc CSV doc packet, is like this file path, star doc. But you can think about this is just like a cloud storage, and it's somewhere there. And under that file, there's something called star doc packet. Yeah. Yes, from Azure S3 bucket. So it's basically right now, it's reading the file, you see, 3.4 seconds. And then so we create a table called country. And now you can run it. Again, it doesn't show you like it's too many. So it doesn't show you all at once. If you want to show how many columns, how many rows, like 37,000 rows. Pretty simple, right? But of course, you don't really know where this file is coming from. I can show you the website, where the data coming from. So it's from the website called source, SOURC.coop, source cooperative. So this is a new initiative that store a lot of like vector data in the cloud, and you can get beta source coop. And let me come back to see the file name again. It's open data, Google research, open buildings, view 2. So you come back here, and where is it? Let me say Google open buildings. Okay, it's in here, and then you can browse the data. You can read the documentation if you want to, but basically it's come from here. But it's this data stored in the AWS S3 bucket. And let me read the file path again, right? Buildings, view2, geopacket, admin, country, SSD. So geopacket, where is it? I believe it's this one. And then country, for example, ISO equal to blah blah something, right? So what this one is doing is like it's reading the file for the entire country. So country equal to, I think this one is South Sudan or something. And the same idea in here, right? So if you go in, for example, country ISO because something, you read there's only one file, but some of the country might be have pretty big, might have multiple files. Then it's going to read multiple files altogether. Yeah, these are all pretty small. So it's from the S3 bucket, but you can also do the same thing. You can just read the file in here. So if you click in, right? This is the link, the direct link to the packet file. So earlier we used the S3, but you can actually read it from HTTP or URL. So if you click, it's going to download this one to a computer. So if you have the file on your computer, then you know how to read it, right? So just the same, just passing the file name. But actually, I don't have to. So here I can show you how we're going to do that, right? Let me copy a new code block. So all you need to do is just do something like this. Copy this one and then create a new code block. I'm just showing you how to read the data from the cloud. Basically how to stream the data to your computer without having to download the file. And the file can be many gigabytes, but you only download the small, tiny portion. So here, I can just read. Let me show you like first. On how about this? URL equal to no. We're running out of time, but I just wanted to quickly show you how you read the file from the internet. So here, this is the packet file, right? Copy, and then come back to here, paste, Alt Enter. So first, forget about vector data. So a packet file is, you can think about it as just a table, but there's a spatial column called geometry in there. So the first thing you can try is like con.sql, and then you can from that URL. But usually you need to use f string so that you don't need to type the file name. So you'll be from, oops, Is it from? And then you'll be the URL. So you'll be, what is that? Single quote, and then square brackets, URL. I have the SQL URL lowercase. Here. Is it? Oh, I have two. Oh, I need to have that double quote outside. Okay. And then I can run it. What's wrong? Oh, I need the F. Sorry, I removed the F. This should be like this. You see? Already the share file. So now this file come from the internet. I'm just basically use the regular reading the packet file using. I'm not dealing with Spatial yet, but the reason I'm doing this, I want to see what column in there. So now I know there's a geometry column in there, right? So basically, then you can just do something similar like this. So create a table, and then I can use a new name. So what's the file? What's the file name in here? So AW. I don't know what the country is. So I can say, okay, I'm gonna create a new table called AW, and then select all the columns. Exclude geometry. This is the same thing, except right now I'm doing like this. So you need to just paste in the URL to here, or alternative, I can put like a F. So use the F string because it's already defined a variable. Then it's probably easier. So then I just remove this one in here, and then you'll be curly brackets. Okay, URL, and then this one. Is it right? What's going on? There should be another 3 ending port W, something like this. Okay, so what we're doing is running the SQL statements and then create and then replace the URL with what we use and then run it. You see, it's done. So now I can say AW. See, so it's reading the file. Now you see all the stuff. Now it's converted to column. Nice, right? You can rename this one, rename the column, select geometry as geometry, so that geometry, so that your column name is not this long. Okay, but you need to create table, create or replace. Okay, and then you will run again. It's reading the file and then loading the table in there. So now you should have the table in here. Now it's geometry. Right? So we're reading the file from internet, and you can think about here if you need to do some aggregation, you need to do some summarize or whatever. Then you don't need to read the entire file. You can select just the column or average or whatever, and then you will just read the file. So, and like I said, it's a huge database in here if you want to try it out. So we don't have time to go through, but we do again next time. Show you how to deal with large amount of data. So this is the nice website that you can try out. There are tons of data in there with geospatial components. Okay, so that's all for today. I will see you on Friday.